Okay, so there's usually three techniques you're going to want to use. Desmos, actually, I take it back, four techniques. Desmos, um, substituting for variables, working backwards, or just get creative. Go a little bit higher order critical thinking. So number 15, it's not really a Desmos because I don't know what I would graph, like you got ax, bx plus 2, bx plus 7, 15x squared plus cx plus 14. Substitute for variables. Yes, I could substitute for A, B, or C, but you need to have the variables and the choices too for that strategy to work. Now, working backwards, the question is asking for what C is. So I can assume A is the correct answer and maybe C is 3, but then I don't know how I'm going to verify what A and B would be. Like that just seems complicated. So I'm going to have to get a little creative. So in this case, I see an opportunity to foil the left side. Let's try it, see what happens. For foil it, I get ABX squared plus 2bx, or we'll say 7ax, plus 2bx plus 14. And it's going to equal the other side, which is 15x squared plus cx plus 14. So you know AB equals 15. We know these are the same. And C would have to equal 7a plus 2b. Well, if you think about it, A plus B has to be 5 and 3, right? And that's getting a little creative, like realizing, oh yeah, A, B, and 15, those line up. 7a and 2b, those line up. Or I could reverse it and say A is 3 and B is 5. Well, if A is 5 and B is 3, then I should know what C is. 35 plus 6 or 41. Or if I reverse it, to get D. Now, they put A as a trap because, yeah, I figure, oh, yeah, I see 3 and 5. But that's what A and B are. That's where C is. So that doesn't work. So that's a great example of being creative. It's a tough question, mind you, but that's what happens there. Questions on that one? What I did there. Okay. Yeah, again, if you see an opportunity to foil or factor, you should. And sometimes that makes a certain connection more clear. Like, oh yeah, okay, AB has to be 15. Oh, A plus B is 8. Oh, okay, they have the 3 and they're 3 and 5 or 5 and 3 and whatever. So now let's look at 30. What is this one here? So if you read the question, they're asking you which of the following equations will have the coordinates of the vertex A in the equation itself. So you want basically something in vertex form. You want the coordinates of vertex to appear in the equation. Well, and also when you see the word which, that's usually going to be a process of elimination or working backwards. Okay. Well, look at the choices. One of those four will be in vertex form. Which one do you guys think?
I think it's would it be D?
Yeah, that's it. That's the vertex form. And also, if you were to expand it, it would be this. Or you could go to Desmos or your graphing calculator and graph each equation and see that they're the same equation. So that's another way of looking at it too. But the thing is that A is also the same as the original, but the thing is that you want vertex form. You want the vertex to show because they asked for that. So totally D, 100%. Okay, now this is a prime example using Desmos. Now, if you want something undefined, you have a fraction. What does that mean when a fraction is undefined? You guys know what that means? The denominator equals what when you're undefined?
0.
Exactly. Exactly. Like 1/0, you can't do it. It's not defined. So I need the bottom to be 0. Well, here's what I'm going to do. I'm going to graph that bottom, just the bottom, not the whole thing, just the bottom, and see where it crosses the x-axis. So if you guys can open up Desmos, go ahead and graph that. And just tell me where it crosses the x-axis. Because remember, you cross the x-axis, y is 0.
It crosses the x-axis at 3, 0.
There we go. That's it. That's what makes it undefined. And again, you could do that by hand, but why? Right? It's a waste of time. It's more efficient. You have Desmos, just let Desmos do the dirty work for you. But you have to understand what the question wants, right? You want undefined, you want 0 on the bottom. And then you have to make that connection like, oh yeah, if the bottom is 0, that's an x-intercept. That's a graphical algebraic connection you have to make. But the hope is, as you've gone through enough math, that connection makes sense. If it's not, doesn't make sense. If it wasn't clear to you now, hopefully it's clear now. Because again, the x-intercept is what x equals and y is 0. So now 7. Yeah, I think we have to get a little creative here. I don't think Desmos will do anything for us. I don't see letters in the choices. I don't think the substitution strategy works for us. The substitution strategy will work for the next one. Working backwards could maybe do that. Actually, that probably could work, I suppose. What if you assume that A is the correct answer? So A minus B is 8. If that's true, then what do A and B both equal? So take a moment to think about that. Or you could do it algebraically really quickly. Assuming the first choice is true. So what would A and B equal, guys?
Um, would A be 16 and B be 8?
But then 16 plus 2 is 24, not 2.
Oh,
And
okay, when it's 2.
you've overshot it, yeah.
Oh, so is it just 1 plus 1?
But then 1 minus 1 is 0. It's got to work for both, right?
Oh, okay.
So what you could do is this. You could always go to Desmos. So now you actually can go to Desmos. You can graph that and see where they touch. That could work. Or you can add the equation together by elimination and solve for A and B. It's up to you. Or if you could just think about it. But you know, take a moment. Well, what do A and B equal here? What two numbers add up to 2 but subtract to 8? And again, if you're stuck, just plug into Desmos and it'll tell you. I'll give you a hint. Y is negative. No, there's a some in the chat. Okay, Isaac's got it. Do you guys find it, Mia or Jace?
Yeah, I got the same thing. I got
5 and -3.
Yeah, 5,
Good,
-3.
good, perfect, good. Now, does it make this happy? Let's find out. You have x to the 25th power, that's 5 squared. You have x to the 9th power, that's -3 squared. And that does follow the property of exponents. You subtract them. Yeah, it works. So we got lucky. The first choice did work. If it didn't work, then you gotta next one. Now that was a little labor intensive because you had to like solve a system, or in this case, go to Desmos. So another way you could have done it too, if you get a little creative. Yeah, I mean, using my properties of exponents, I have this. And you realize, oh yeah, okay, that's true. And if you factor it, and you know a plus b is 2. Then a minus b is 8. Yeah. Okay. Now, this is a great strategy as a substitution strategy. Sorry, great problem to use a substitution. Sorry, I've been working all day today. Great problem to use a substitution strategy. You see letters into choices. We should plug in a number. And plug in a number, it's easy. Like say 1. If you plug in 1, what does that expression equal? 5x minus 2 over x plus 3.
Would it just be A?
Well, hold on a sec. Let's work this out first before we jump the gun. What does that equal when I plug 1 for x?
Oh, it would just be 5.
3.
Oh, wait,
5
for the
minus
top part?
3/4.
3/4. Yeah, no, just this. Don't worry about the choices for now.
Okay.
I let x equal a number. Yeah, and let me check the chat. Yeah, it'll be 3/4. When x is 1, you have 5 minus 2 over 1 plus 3. Okay, now let's look at the choices. You need one of these to equal 3/4. Remember, x is 1. Now let's look at a. Does a equal 3/4? No, that's 3 over 3, right? That's out. Does b equal 3/4? No, it's 5 minus 2/3. That's 4 1/3. That's out. Does c work? That's 5 minus 2/4. That's actually 4.5. Too high. Out. Better be D, or I don't know what else to do. Or maybe I made this careless mistake somewhere. Yes, that does work. Because you get 20 out of 4 minus 17 out of 4. Yep. And I get D as a dog. Okay, let's keep moving. This one's kind of easy. It's just more kind of let's just clean it up, simplify it, match with the other side. We'll skip it for now because I don't know if that's really worth our time. 20 is a good one, but I'm gonna skip that for now as well. But let's look at 7. 7 uses the phrase which of the following, which is work backwards. And what do they want? They want an equation that shows the x-intercept. So it's got to be an intercept form. So look at the choices. Which one's an intercept form? And which one matches the equation that we have up above anyway. But intercept form means it has to be factored. So you have to be able to identify the x-intercepts. And you can always graph in Desmos too if you want to see what are the x-intercepts. And do the x-intercepts appear in the equation? What do you guys think? So which one would it match with?
I think B.
But that's not intercept form though. That's vertex form.
Would intercept form be C?
No, that's not intercept form either.
Ah.
Intercept form's this, guys.
Oh,
It's factored.
Oh,
C
okay.
is not factored. It's gotta be fully factored like that.
yeah, then it would be
Okay.
D because that's the only one, right?
And also, if you were to graph it on Desmos, you would see it crosses at 2 and 4.
Oh, yeah, okay, I see that. I was
So-
looking for because the vertex was 3, -1.
But they didn't want that, right? So we gotta go with what they want.
Okay.
Okay, let me zoom out a tad. Okay, again, another problem that deals with which of the following. Now, of course, you still need to know the concept. You gotta know your function notation. So they give you the graph of fx up above. They want to know which of the following equals 1. So we see Roman numeral 1. When you plug a -4 into the function, you want it to equal 1. Well, let's locate -4 for x. Does y equal 1? Yeah. So definitely want 1. Test the other ones out. Do these each equal 1?
Would it be 1 and 3 only?
Well, actually, 2 works too.
It does? Oh, because it's okay. I was thinking negative.
Yep,
My fault.
Yep. That's all 3. Yeah, again, which of the following? They want process elimination. Okay, now let's go back to this one. Again, we see which of the following, but we're going to use Desmos to help us as well. This is a graphical type of situation. You have 2 equations here. Now, the first thing I would do is graph y equals 3. And then assume that A works. So you're going to plug a -2 for little a and 2 for little b. And then they want exactly 2 real solutions, but they want 2 points of intersection. So, yeah, let's see if this works. If it doesn't work, try the next choice. But you're going to have to graph y equals 3 and y equals whatever using different constants from each choice until you see one that works. So does A work? Did it touch twice? Nope. Okay, so it's out. Try B. Does B work? Did it touch twice?
Yeah, I think it's B.
Yeah, it's B. Got it. No, that's all right. We don't need that one. Let's do 6. 6 is another good one where we use Desmos. We gotta find the point of intersection.
It's just the point of intersection is where they're
Right.
equals.
Yeah, and then you want to take the difference in the coordinates.
Okay, I
So-
got
so-
-4.
Yep. Yeah, I think it's 2, 6. Yep. Perfect. Yeah, it's just use it. Don't need to do it by hand, right? It's not necessary. I'm gonna skip around a little bit here. Actually, let me jump down. Let me jump to 29. Okay. So let M equal 1. So I see letters, right? I see letters in the choices. They say X is the average of M and 9. Again, choose easy numbers when you plug in. Like, I'm going to choose, M's kind of independent. Let M be 1. What would X equal in this case? If I let M be 1, what does X equal? What's the average of 1 and 9? Remember, average is add up, divide by 2.
Is it 5?
Yeah, exactly. That's all.
Okay.
I mean, of course, if you have more numbers, you divide by a number of numbers. Okay. So now that we're committed to M being 1, that's going to be 2 and 15 and 3 and 18. So now let's figure out Y and Z. Y is the average of 2 and 15, Z is the average of 3 and 18. So what's the average of 2 and 15? It'll be a decimal, by the way.
8.5.
Z.
And then will the other one be 10.5?
Perfect. Now average those 3 numbers, because that's what the question wants. They want the average of X, Y, and Z. So you got to add up those 3 numbers that we got for X, Y, and Z and divide by 3, of course. We have 3 numbers.
I got 8.
Perfect. Now plug 1 into each choice, because we remember M is still 1, doesn't change. Which one equals 8? of these four choices?
B.
There you go. Got it. Excellent. So we turn the problem that seems kind of hard to the problem that's more manageable, right? When we plug in numbers for the letters. So, and that's the trigger. Like when you see letters in the choices and letters in the problem, that's how you kind of know. And of course, go with don't say M is like 8.6 or 17.4. Like, don't choose something kind of random. Like, choose numbers easy to work with, even though the answer still could have worked. Also, if there are any conditions set forth for the variable, like if the variable has an even number or an integer, and abide by those conditions, but otherwise, yeah, total freedom. And if you do have total freedom, choose easy numbers, Okay. I kind of like, hold on a sec here. We'll do a couple more, then we'll move on to some grammar work. Not grammar work, sorry. Reading and writing, but there'll be some grammar involved. All right, here. Which of the following, right? Now, D is a y coordinate of the vertex. Now you could find the x-intercept, but actually let me back up a little bit here. Let's just look at the choices. Well, first off, let A equal a number. Let A equal 1. Okay, I see letters on the choices. Sorry, I'm kind of going against what I was preaching. You see letters in the choices. You should plug in numbers. So now you're graphing this. So here's what I like you to do. Find me the vertex. Graph that equation, find me the vertex. What's a vertex?
-1, -9.
Perfect, good. Now, they want to know which of all equals D. Well, remember, A is 1. If I plug a 1 to each choice, which one equals -9?
Yeah, it's
That
just
one. Yeah, that's it. Yep. Correct. So again, yeah, I was kind of just I don't know why I was drawing a graph. I mean, yes, you can do that, but we could also just use Desmos. Okay, we'll see one more, and then we'll move on to reading and writing. Let's look at 11. Okay, let's graph in a Desmos. And you want to see how many times they touch. Just graph and see how many times they touch. That's all.
I got twice.
Yep, that's it. You got it. Yeah, so again, all right, let's move on to some reading and writing practice. I did this with a student earlier today, so I think I remember these pretty well. Let me close this down. Um, let's try these two here. So this is a little bit of vocab. You just have to pick the word that fits. Go and read both if you can read it. If you need me to zoom in, let me know. And just let me know what choices you think you guys like for this one. I'm gonna read it too. I'm hearing B and C. You guys agree? Yep. Let me look at two really quickly. Okay. Let's try a different type. Main purpose of the text. Let me zoom in a tad. Yeah. Don't try 7. You want the main purpose. Yeah, I agree. Yep. And then let's try this one here. So a slightly different question. So which choice best describes the function that only presents in the text as a whole? We want the function of it.
I'm guiding her like to the
I'm not really sure. Could you like help explain this one?
Sure, let's do it. Lily had no real intimacy with nature, but she had a passion for the appropriate and could be keenly sensitive to scene, which is the fitting background of her own sensations. The landscape outspread below her seemed an enlargement of her present mood, and she found something of herself in its calmness, breath, and its long period. So basically, she's the landscape kind of represents how she feels, right? She feels calm, you know. And the enlargement of her present mood, okay. on the near slopes of sugar maples, where were like pyres of lights. Lower down was a massive of great orchards, and here and there are the lingering green of an oak grove. So it just sounds all very pleasant and nice. Um, yeah, it's a little tricky the way. Yeah, okay, I can see why you guys are stuck. So let's look at C for example. It says she could be keenly sensitive to a scene, which is fitting, which is the fitting back of her own sensation of how she feels. And then to give an example of that, right? So I kind of like C a lot. But it actually could be D too, though. Hold on. It illustrates an idea that was introduced. No, it's not so much an idea. It's giving us an example, actually. So I kind of like D because I don't think it's really an idea. But it's not an internal conflict at all, because it all sounds very pleasant. So I don't like B. And A, yeah, but it's not really what it's doing. It's really trying to give an example of how she's feeling, and it is expanding on what was said earlier. So I'm gonna go with C in that one. Let's take a quick peek, see how things were going. Oh shoot, it was D. Never mind. Yikes. Okay, let's do another one. That was D. Really? Oh shoot, I misread it. I misread it. The next sentence doesn't do that. Sorry, I was thinking the first sentence. Yeah, sorry, my bad. That second sentence, the next sentence is the third sentence. That doesn't make any sense. Sorry. I totally got confused. It should be D. D does make sense. Okay, let's try another one just to be sure we got it. So we'll read this one here for ourselves and we'll compare.
You get a 2019. Oh, wow.
I would say B.
I would say it's a bit methodology, actually. Because they're explaining like how they did this, right? And their method of like comparing over 20,000 animals. It's not there's nothing specific there yet. Um, it's not summarizing the results. We don't know what the results are yet either. But it does talk about what they did, how they went about the study. Yeah, that's why it's C for that one. So
Okay.
let's try some grammar. So I think we do need to hit that up. Um, actually, here we go. Let me zoom out. So convention is standard English. That's pure grammar. Let's look at 1 and 2.
Oh, yeah. Maybe it's gonna be. I can barely twist. I can barely get to the. It's hard to twist. Dude, I get worried like my Oh, he hurt his shoulder. Oh, almost. He hurt his shoulder.
So we got, you have an answer for one?
I said C.
Yeah, we went to dinner at Cal.
Let's see what Isaac's got here. Yeah, we want to say C for that one because yeah, they are wouldn't make sense, right? Yeah, it's gotta be C, it's gotta be possessive. And take a look at 2.
I know, yeah. It's so true.
And just, you know, when you put a title before someone's name, you don't need a comma between the title or the name. Or sorry, title and the name.
So then it won't be A or B because we don't need that.
Right. Now, D doesn't work because D's a little too choppy. I would just go C. You don't need a pause at all.
Okay,
A film that's critics in a trend claims, blah, blah, blah. Yeah.
sure.
Yeah, if you're gonna put 2 commas, then the middle phrase becomes what we call a non-essential clause, which is not what we're after here. That's not what we want. So, because you do need that phrase, claims. Let's jump to another one that's a little bit that covers some other important stuff. On grammar. Here we go. Let's do 7 and 8.
Chris is like, you don't have to have me work. Oh, in America? So I hear that. If we move there now, does that mean that we're gonna? Like we got all that. We can condition. Okinawa. Might add 5 years. Oh, yeah. Mobility and.
Okay, you guys have an answer for 7 and 8?
For 7, I said C, and then 8, I also said C.
So both are incorrect, unfortunately. Let me help you out. Let's talk about 7 first. So what Isaac's got. Yeah, C doesn't work for 8 either. So let's talk about 7. You want though to contrast with the first sentence. Because read again. In 1943, in the midst of World War II, mathematics professor Grace Hopper was recruited by the U.S. military to help the war effort by solving complex equations. Hopper's subsequent career would involve more than just that, however, or more than that, though. You need to make sure the second sentence contrasts with the first, so those got to be part of the first sentence. That's why C wouldn't work.
So it would have to be A.
Yeah, it's got to be A. Yeah,
All right.
you can't go B because that would be as a pioneer in computer program, Hopper would help usher in the digital age. Yeah, B and D would be run-ons. So you need a bit of a longer pause and a comma. You could have done semicolon or colon, either's fine. Or you could have done a period and started a new sentence. But the things that as a pioneering, as is not capitalized. So yeah. Now for 8, the reason why C doesn't work. Who recovered 2 years later? Henry recovered, right?
Yeah.
Not his reign. His reign did not recover. Henry himself recovered because he's the one who became unfit to rule because he became gravely ill. So that's what we call a modifier. It's a description. It's a phrase that describes something. And whatever your modifier describing has got to come right after it, like immediately after it. But you're talking about his reign. Same thing with B. You're talking about his reign. And D, you're talking about it. It's got to be A. Henry resumed his reign, forcing blah, blah, blah. So, and actually, I have a little thing here I could share on that. Yeah, if you look at this one here, an elementary school teacher from Arkansas increased funding and public support for public libraries, what Bessie Bowmore advocated for. Who was the elementary school teacher from Arkansas? Not the funding, but her, Bessie Bowmore. So you guys say her name right after that phrase. Otherwise, we say it's a misplaced modifier. So it sounds kind of weird because you hear the word modify, I think change, but a modifier is just simply a phrase. And it's got to be right next to whatever it's describing. Otherwise, it's misplaced. Sometimes it's called a dangling modifier too. That could happen. Actually, that was dangling we were just talking about. Sorry. Well, same thing. They're very. I can't even tell just between the two types. But the bottom line is like here. Like Paul Conrad is a cartoonist known for his political satire. He spent nearly 3 decades on staff at the LA Times. So the satires spent nearly 3 decades. No, it was Paul Conrad who did. So you got to rephrase it. Like Paul Conrad, a cartoonist known, spent nearly, that could work. Because then you have this phrase here that's not needed because that's 2 commas. It's not essential, but it's fine. Paul Conrad spent nearly 3 decades. That works. Yeah, those work too. So, okay, I do have to wrap up in a couple minutes. We'll try one more problem type. Let's try number 2. So this is called like rhetorical analysis, where you're just using information here, and then what they want is the student wants to present the study and the findings. Which one does that the best? You want to make sure the findings are presented. which is basically the bones belong to juveniles. And the study is that, they found these jawbones and they wanted to investigate it.
So would it be D then?
Yeah, totally. 100%. Yep, good. He'll go and stop there for today. Let me stop the recording.